Hi, in this video, we are going to go through the common mistake that always made by students when answering questions about chemical formula. If you notice, the mass of carbon dioxide and water produced are given in these three questions. At the same time, element of the compound also given. First common mistake that noticed is student has no idea how to determine the mass of carbon and hydrogen. At the same time, also the third element. In the example given in this video, the third element is either oxygen or nitrogen. But actually, the third element can be any element according to the questions. Okay, students A looks like have idea how to determine the mass of carbon and also the mass of hydrogen. Later we are going to discuss there is another mistake here. But students A has no idea how to determine the mass of oxygen. Next, student B can find the number of mole, but then student B has no idea how to determine the mass of carbon and hydrogen. While student C looks like has idea how to determine the mass of nitrogen. But then we can notice the mass of carbon or hydrogen that substitute in, the total mass is greater than the mass of the compound. So that's why the students C unable to get the mass of nitrogen here. Okay, student D also show that there is no idea in determining the mass of carbon, hydrogen, and also the nitrogen. And then we also notice there's another problem here for this answer. Next, we notice students not alert with the illogical calculated answer. For example, question 6. Given the compound is 4.624 gram, but then if you total out the the mass of oxygen, the mass of hydrogen, and the mass of carbon, it is more than 4.624 gram. Second, question 41 is mentioned there is 0.125 gram of X. If these are the answer that you calculated when you total up, no need to total up, but only just look for either one of these mass of hydrogen is already exceed the mass of compound X. So this one also is considered illogical calculated answer. Student C, if we total up this 40.1 plus 3 plus 42, it is supposed a whole number, but here student get decimal places. Students D also, the mass of the compound is 0.125. After you do the minus operation, then you notice that your final answer is 0.28, which is greater than 0.125. Next, we notice that students didn't identify the element correctly. For example, the question is mentioned carbon, hydrogen, and nitrogen. But the students write oxygen. Common mistake 4. Students forgot about the mole ratio of hydrogen atoms. There are 2 hydrogen atoms in the water, so supposedly here should be 2, not 1. These students also doing the same mistake. The last common mistake that we identify is students did not keep 4 decimal place in their all significant figures in their working steps. For example, these students even though try to keep in 3 decimal place, but then you look at here, the simplest ratio are not in the whole number. If this is the case happen, actually the students supposedly have to multiply with 4 so that can get a whole number answer. But then maybe we'll notice that it is not that logic with the chemical formulas that you obtain. If this happens, please next time try to work back the calculation step and then try to keep in 4 decimal place or 4 significant figures. Well done and congratulations to these students. This is a very good example. Students calculate the mass of the carbon, hydrogen and oxygen. Then they move the mass in a table and then with the number of mole, simplest ratio, and then look for the simplest ratios, and last is the empirical formula. Let's summarize this topic. There are two types of chemical formula. First, empirical formula. Second, molecular formula. To identify the empirical formula, first we need to know what are the elements in the compound. Second, we have to know the mass in terms of gram. In the question, the mass can be given directly, or sometimes the mass will be given in percentage. If this case happens, we need to write down, assume there is 100 grams of sample above the table. Second, mass of carbon dioxide and water can be given. From the mass of carbon dioxide and water, we can find out the mass of carbon. For example, if there is 44 grams of carbon dioxide, always will consist 12 grams of carbon. So now we need to find out what is the mass of the carbon in the sample. So we need to know the mass of carbon dioxide. So when then we use the crossover multiplication, then we will get the mass of carbon in the sample. Similar condition can be used to determine the mass of hydrogen. However, have to make alert here is 1 mole of water, every 18 grams of water consists 2 grams of hydrogen, because the formula for the water H2O consists 2 hydrogen atoms. After using the crossover multiplication, we will notice that if we want to find the mass of hydrogen in the sample, we always use mass of water in the question, multiply with 2 and then divide by 18. If there is third element in this compound, we are going to use the mass of the sample minus the mass of carbon and mass of hydrogen. If we can determine the mass correctly, then there should be no problem to determine the number of moles. After we know the number of moles, we need to find the simplest ratio and then make sure the simplest ratio always in whole number. Then we can know the empirical formula. After we get the empirical formula, we are able to determine the molecular formula if the molar mass is given. So we can always find out the n value, at where keep in mind that the n value always should be whole number or very near to the whole number. So I think this is the summary for this topic. Okay, thank you for watching and hope you get some idea from this video. See you!